Hi everyone, welcome back to DD Happy Chemistry Learning. In today's session, we are going to discuss about isoelectronic species, isostructural species and isostar pairs. Okay, now we will move on to the session. Yes, isoelectronic species, they are atoms or ions that have same number of electrons. Okay, here you should note that it has equal number of electrons but different elements, right? So taking an example, Na plus and F minus. Here you can see Na has the atomic number of 11 and fluorine you have 9, right? So the number of electron present in sodium will be 11 and fluorine will be 9. When it has the charge Na plus, yes, you will be minusing 1 electron from it. 11 minus 1, you will be getting 10 electrons. Like that, in fluorine F minus, you will be adding 1 electron, that is 9 plus 1, you will be getting 10 electrons. Okay, hence these two has same number of electrons. These two are isoelectronic species, right? Okay, taking another example, that is F minus and O2 minus. Suppose if it is given like fluorine and O2 minus is given, that is not isoelectronic species. When it is F minus and O2 minus, they are considered to be isoelectronic species, right? Because fluorine has atomic number 9, hence the electronic configuration is 1s2, 2s2, 2p5, right? Like that, for oxygen it has 1s2, 2p2, 2p4. Okay, so F minus means you will be adding 1 electron and O2 minus means you will be adding 2 electrons. So as a total you will be getting 10 electrons. So then only it is considered as isoelectronic species, right? So F minus and O2 minus are isoelectronic species. Okay, we will see another thing. Suppose you take elements from 16 to 20, that is from sulfur to calcium. So sulfur, chlorine, argon, potassium and calcium. Okay, so they have the atomic number like 16, 17, 18, 19, 20, hence the electron present in it also 16, 17, 18, 19, 20. So if it is charged, okay, if S2 minus and Cl minus and it has no charge, and K plus and calcium 2 plus, the corresponding electron will be 18, 18, 18, 18, 18, right? So then it is, these all species are considered to be isoelectronic species. Okay, did you get my point? Without these charges, they are not isoelectronic species. Okay, so when it bears, sulfur bears 2 minus and potassium bears plus charge, they both have same number of electrons and then it is said to be isoelectronic species, right? And another thing is that here the atomic radius is inversely proportional to the atomic number. Okay, you can see here, let us take, okay, calcium. Okay, calcium has the highest atomic number, right? It has 20. But when you see the atomic radius, you can observe that calcium has the smallest atomic radius. Yes, like you know that when an atom bears an positive charge, it has the, yes, more number of effective nuclear charge, hence the atomic radius will be decreasing. It has the small size, right? As you go from calcium, potassium, or argon, chlorine, sulfur, this is the trend in which you can observe the size increases. Yes, so you should note this point. Okay, yes. Now we will see the isostructural species, okay, where the species which have same shape and hybridization. Okay, now we can take the example CO2 and XeF2. Well, for carbon you have 1, 2, 3, 4 electron, valence electron, right, and oxygen will bond with double bond, right, so you will be getting sp. Yes, two bonds, so it's correspond to sp, and the geometry is linear, and when you consider the shape, it has no lone pair, hence it is linear. Yes, right. When you see here for XeF2, yes, you have two bonded fluorine and you have three lone pairs of electrons, so two bond pairs plus three lone pairs, you will be getting sp3d. Okay, and the geometry, corresponding geometry is trigonal bipyramidal, and the corresponding shape is linear. Right here you can see the shapes are linear, hence they are said to be isostructural species. Here you should also give keen importance to the difference in shape and structure. Okay, you should not consider the geometry of the molecule, you should see the shape of the molecule, right? Hence these two are considered to be isostructural species, right? It is the structure of that CO2 and XeF2. So linear, you can observe the structure linear, right? Here also X is bonded with 2F, right? Yes, well, okay, now we will solve one question. Which of the following pairs of compounds is isoelectronic and isostructural? You have given with this set of options, right? We will be solving one by one. Like IF3, you have 7 valence electron for iodine, right? Then for fluorine, 7 into 3, you will be getting 28. Okay, solve like that. Okay, I'm not explaining in detail. So this is the total number of electrons we will be obtaining, right? Hence you can see XeF2 and IBr2 has the same number of electrons. Hence these are considered to be isoelectronic species. And another thing, we should also see whether they are isostructural. Well, yes, that is IBr2 minus and XeF2. Yes, and now only the set I have chosen which have the same number of electrons. Now we will predict the shape. Okay, first we will predict as usual the hybridization and its corresponding shape, right? The valence electron of our iodine is 7 and it has 2 bond pairs and 3 lone pairs, hence it is the total number you get 5, right? And the corresponding hybridization is sp3d, and hence it has 3 lone pairs, it has linear shape. For XeF2, like that, it has 2 bond pairs plus 3 lone pairs, hence the hybridization is sp3d, so corresponding shape is linear, right? So this has both isostructural and isoelectronic species, so option D is the correct answer. Yes, right. Now we will see the next one, that is isostar pairs. Here you can see they will have atoms, like atoms, molecules or ions of similar size containing the same number of atoms and valence electrons. Okay, they will be having similar size and same number of atoms and valence electron. Okay, for example, you can take F minus and O2 minus. you have, they will be isostar with neon. Okay, and like that O2 also will be isostar with neon and fluorine. So in elaborately we will be discussing in next example. Okay, now you can take CH4 and NH4 plus. Okay, so we will be seeing whether it has same number of atoms, same number of electrons, structure and valence electron. Okay, while seeing atoms, CH4 has 5, right, and NH4 plus also have 5 atoms. Moving to the electrons present, you have 6 plus 4, 10 electrons, right? Atomic number 6 plus 4. Okay, you will be getting 10 electrons. While seeing here, you have 7 plus 4 minus 1. Because of this positive charge, you will be getting 10 electrons. Moving to the structure, yes, you will be getting 4 bond pairs only, so no lone pair, so it will be corresponding to sp3 hybridization, that is tetrahedral shape. In NH4 plus, same, right? It will be, and nitrogen will have 1 2 3 4 5 valence electron, right? And you will be neglecting this electron due to the presence of one positive charge, and here also it has no lone pair, it has sp3 hybridization, so the structure is tetrahedral. Okay, so number of atom is same, number of electron is same, structure is same. Now we will see the valence electron. So here valence electron 4 plus 4, you are getting 8 electrons, and here when we are seeing 5 plus 4 minus 1, 8 electrons. The valence electron also it has same, so these two are considered to be isostar pair, right? Okay, just I have just taken here to emphasize that the valence electron should be same in order to be it is isostar. Okay, here you can see CO2 and XCF2, we have already seen it, they are isoelectronic, right? But here you can see the valence electron is not same, hence they are not considered to be isostar pair. Yes, but CH4 and NH4 plus has same number of valence electron, hence they are considered to be isostar pairs. Okay, I hope you would have understand this concept well. To summarize, for isoelectronic species, it will have same number of electrons, and isostructural it has same shape and hybridization, and isosteres have same number of atoms and valence electrons. Okay, yes, I hope you are all clear with the concept and you will be able to solve the questions relating to that. Okay, I will also solve some questions relating to it, and also I will be posting some questions for you to solve. Yes, thank you students, that's all for today's session. We will meet in the next session.